Our first speaker is David Haslett. He'll be delivering his paper, When Words Impinge, Overlapping Sounds and Meanings in Low-Frequency Words. And the authors are David Haslett and Zhenguang.
Cool, okay. Hello, my name is Dave Haslett. I'm an old PhD student from the Chinese University of Hong Kong. I'm going to apologize in advance because my presentation is long, so I'm just going to talk very fast. I'm presenting on behalf of myself and my supervisor, Gary Chai, and I'm going to be discussing the tendency for words with closely related meanings to sound similar, that is to say, to sound more similar than would be expected by chance in an arbitrary lexicon. So to kick off, there are a few ways in which the sound of a word can provide information about the meaning of that word. One case is iconicity, where the sound of the word in some sense resembles the meaning. Yesterday, Elsie Kaiser gave a talk about the Kika-Buba effect. That would be an example of this. But there's also systematicity, in which the sound of a word does not resemble its meaning, but rather resembles the sounds of other words that are in some way semantically related. So for example, nouns tend to share phonological cues, and verbs tend to share different phonological cues. Importantly, systematicity is generally defined as involving statistical regularities across a large class of words, so it applies to things like nouns and verbs, not to specific word meanings. And yet, of course, there are cases of similar sounding words that are also similar in meaning. For example, impinge and infringe, things like this. And my question is basically, is this are these exceptions that prove the rule, or is this tendency for words with similar meanings to sound similar, does it also apply to word meanings of like individual words like these, or pairs of words like this? So I'll provide evidence that I'll try to convince you that that is the case, where within English, words with closely related meanings do tend to sound more similar than would be expected by chance. And this is more pronounced in words that are low in frequency and words with abstract meanings. So systematicity is, most often the evidence for it comes from correlations, small but significant correlations between the meanings of words and the sounds of those words. This has been found in most of 100 languages studied by Isabelle Dautriche and colleagues. It's been found when more carefully controlling for morphological relatedness in English, Spanish, and Korean. And it's been found when further controlling for etymological relatedness in English. And in that 2014 paper by Monahan and colleagues, they provide further evidence that these correlations are not due to clusters of words that sound similar, but rather it's due to very sort of, again, statistical regularities across large categories of words. So you get the whole lexicon, out of the whole lexicon there emerges these tendencies, but they're not found in pairs of words or small clusters of words. So yeah, subtle similarities, not conspicuous similarities, subtle relatedness in meaning, not conspicuous relatedness at the level of individual word meanings. For example, marble is a very typical sounding noun, but does not have any conspicuous cues that tell you it's a noun. Rather, you can learn to more easily recognize it as a noun once you encounter a large number of nouns and get used to these statistical regularities. And one of the interesting points about this characterization of systematicity is that it can be compatible with arbitrariness, where you can have systematicity at the level of broad categories, but arbitrariness at the level of individual word meanings. And so by arbitrariness, I'm referring to basically a lack of systematicity, the tendency for words that are closely related in meaning to sound unlike one another. For example, marble and granite, very closely related meanings, but they sound quite different from one another. The fact that they sound different makes it easier to acquire that subtle distinction in semantics and makes it easier to maintain and convey that. So people are not likely to confuse the meanings of marble and granite despite having similar meanings, precisely because they sound different from one another. And again, the takeaway, the relevant point here is that arbitrariness at the level of individual word meanings is compatible with systematicity, so long as systematicity is believed to be restricted to broad categories. But of course, category membership and word meaning are sort of related to one another. They lie in a continuum. So there's a nice illustration from Alan Nielsen's dissertation where he talks about sort of, you've got nouns versus verbs, a very sort of high level, so semantically low level, broad category distinction, but you can have you can sort of increase the semantic specificity until you get to something like farm animals versus household pets, where it's still category membership, but there's something much more like word meaning contained in those categories. So the members of those categories have a lot in common semantically. One real-world example of this is phonesthemes. So words in English like glow, gleam, glint, glisten, glitter, glimmer. They begin with that GL sound. They share a semantic feature. And so they're often used as an example of systematicity. But it complicates the idea that we can have arbitrariness at the level of individual word meanings if those are indeed systematic, given that these words are conspicuous, have conspicuous similarities in both form and meaning. They seem to be not arbitrary at all. And so the research question is, do we find this sort of tendency for words with closely related meanings to sound more similar? Is it true that systematicity is restrained or limited to broad categories, or do we also find something like systematicity at the level of individual word meanings? So to investigate this, we first had to gather pairs of words. Can everyone hear me okay? I feel like I'm moving around the mic, all right. First, we gathered pairs of words which do have closely related meanings. So one way to do this is with associates. That's responses in a word association task. For example, if you say banana, people will often respond with apple. But one problem with associates is that in some cases they are formal. So a common response to bandana is banana. These words are formally related, not semantically related. So we also looked at semantic neighbors from distributional semantic models, things like latent semantic analysis or word2vec. And in models like this, we will find that words like banana and pineapple are considered semantic neighbors because they occur in similar linguistic contexts. And yet there are still problems with distributional semantic models when it comes to word frequency. Words that are low in frequency occur in few linguistic contexts and therefore have less reliable word embeddings or word vectors. And so we also just looked at synonyms. So you can look at a low frequency word like melange and find a reliable synonym by using thesauri and stuff like that. In this case, we used the syn-r package, SYN. We can talk about the details later if you'd like. For the materials, we focused only on monomorphemic targets paired with monomorphemic words. So monomorphemic associates, monomorphemic neighbors, synonyms, because we don't want to compare, for example, quickly and quicker. The fact that they overlap in both form and meaning is not very interesting or informative. We're more interested in comparing things like quick and fast. So with our associates, when we're looking at the word association data, we get 5,000 target words. Each of those has an average of 22 associates. We've got 3 different sets of semantic neighbors based on 3 different semantic spaces: a latent semantic analysis space, a word2vec space, and a hyperspace analog to language space. Each of those have close to 8,000 target words, and each of those target words have 10 to 15 neighbors depending on the semantic space you use. And we also gathered synonyms, over 6,000 target words. Each of those has, and with 46 synonyms on average per target word. To measure the similarity of these pairs of words, we used Levenshtein distance. That can be either orthographic or phonological. So nurse versus hearse, for example, differs in 3 letters. That would be an orthographic Levenshtein distance of 3. Differs in 1 phoneme, so a phonological edit distance of 1. We then normalize these for length by dividing the raw Levenshtein distance by the length of the longer of the 2 words, so the number of letters or number of sounds. So cat to feline, they differ in 6 letters. You have to change 6 letters to make cat identical to feline. The longer of the 2 words, feline, has 6 letters. So that gives you a normalized edit distance of 1. And there's a range from 0 to 1 for the normalized distances. 0 would mean identical, 0 edits required. 1 means they differ in all possible letters or sounds. And then finally, we averaged all these per target word. So again, recall that we have close to 50 synonyms per target word, around 10 semantic neighbors per target word. And so we averaged all of the synonyms and associates per target word in separate models. For example, if you've got 2 associates with adapt to evolve, they differ in all possible letters. So again, a normalized edit distance of 1. They differ in only 1 out of 5 letters. Sorry, adapt and adopt differ in only 1 out of 5 letters. That gives you a normalized distance of 0.2. If those are the only 2 associates, you would get a mean normalized edit distance of 0.6, the average of those 2 distances for the target word adapt. The first analysis is just determining whether or not the similarity of these semantically related words is more or less or identical to, or whether it differs from randomly paired words. Again, if the lexicon is arbitrary, you would expect semantically related words and randomly paired words to ultimately have, to not differ in terms of how formally similar they are. Yeah, so we're looking at the distance between random words versus semantically related words. So for example, you can take banana to apple or cat to dog. Those are associates, they're semantically related. randomize the associates and you get banana to cat and dog to apple, something like that. So we did 1,000 random samples for each of these sets of edit distances for each of these sets of semantically related words, and then did 1,000 t-tests comparing the semantically related words to the randomly paired words, comparing the edit distance for the paired words. Keep in mind, we've got 10 sets of edit distances. So there are, again, synonyms, associates, and semantic neighbors. That's 5 sets of words. And for each of those, we're looking at both orthographic and phonological edit distance, a total of 10. And so we get, in the left column, we've got the semantically related words. So these are, again, 5 comparisons. 5 comparisons of orthographic edit distance for synonyms, associates, and 3 sets of semantic neighbors. If you look close, it's not very clear, I apologize. If you look closely, you can see that the range of the mean values for the randomly paired words, the lowest possible value, the minimum value, is still significantly greater than the semantically related words, which means that they've got a greater edit distance, which means they are less similar in form. It's easier perhaps when you look at this graph, although I'm not sure how the colors are. There's a large overlap in that sort of bright purple area, but the semantically related words in the pale purple, light blue thing, they tend towards the left where they've got a smaller edit distance on average, or a smaller edit distance in the aggregate, whereas the light red for the randomly paired words tend towards the right side, so they've got a greater edit distance, they are less similar in form. And the same sort of pattern of results for phonological edit distance looks the same. And in terms of the t-tests, again, there's 10,000 t-tests, 1,000 t-tests for each of these, 1,000 random samples for each of these orthographic versus phonological, or 5 sets of semantically related words. In every single case, highly significantly different. Obviously, this provides, I think, pretty clear evidence that words that are closely related in meaning sound more similar than would be expected by chance if they are randomly paired. The second relationship, or the second analysis, is looking at the relationship between these edit distances and other lexical variables. So we did 10 multiple regression models looking at the various edit distances as predicted by word frequency, age of acquisition, concreteness ratings, as well as controlling for neighborhood density and bigram frequency. The reason for including these, it's been previously found that low frequency words tend to be more systematic, but that's systematicity at the level of broad categories again. If we find the same effect, we would expect a positive relationship, such that as frequency increases, then distance also increases, which means that the lower frequency words tend to have the smaller distance, they're more similar. Similarly for early acquired words, early acquired words have been found to be more systematic at the category level. So if we find the same thing, we would again expect a positive relationship. Age of acquisition goes up, distance goes up. Words that are earlier acquired tend to have a smaller edit distance on average. It's also been found that iconic words tend to be more concrete. This does not apply to systematicity, but I think it's an interesting point of comparison. So if we found the same thing that has been previously found for iconic words, then we would expect a negative relationship, where as concreteness goes up, edit distance goes down, so they become more similar in form as they become more concrete in meaning. And we also included, again, neighborhood density and bigram frequency, just because these are words that have frequent bigrams or that come from dense neighborhoods are more likely to sound like other words, and that doesn't really tell us anything about the semantic relatedness. We want to control for overall formal typicality and focus on the similarity of words that are, again, semantically related. So again, this is the results from 5 models, 5 regression models looking at the orthographic edit distance for each of these types of semantic relatedness. In all cases, I apologize just for showing that they're significant, but I think it's easier to see the trend this way. In all cases, you can see that there is a significantly positive relationship with concreteness, which again means that, which is the opposite of what you would expect with iconicity, or what's been found for iconicity, or as concreteness rating goes up, distance also goes up, which means that words with more abstract meanings tend to have more similar forms, or be more similar in form to semantically related words. There's also seems to be a positive effect with frequency, so I can show it for you there. Obviously, it's a very small slope, a very small effect, which is unsurprising. You wouldn't expect this to be the main driving force. But there's a positive relationship between frequency and the orthographic edit distance of synonyms, again suggesting that as frequency goes up, edit distance goes up. So words that are lower in frequency tend to be more similar to semantically related words. Very similar pattern with the phonological edit distance. Clearly, there's no clear pattern for the age of acquisition stuff, but for both concreteness and frequency, it appears that they have a positive relationship with edit distance, again suggesting that abstract words and low frequency words are more likely to sound similar to words that are very similar in meaning. And this has been, as I mentioned earlier, we tried to control for orthographic density and bigram frequency. But it's always possible that confounds will sneak in. So for example, you can only include so many covariates before you get problems with collinearity. So to validate these results, we further tested for, again, the random samples. So instead of predicting the edit distance between semantically related words, we compared the edit distance between randomly paired words. And we found that in almost no cases do you get a significantly positive relationship, which suggests that the positive relationship is due to the similarity between semantically related words. It's not just a neighborhood effect. Okay, I've got to hurry up. To summarize, so far I've shown in analysis 1 that words that are semantically related tend to be more similar than would be expected by chance in an arbitrary lexicon. In analysis 2, we've tried to show, or we have shown, I think, that this effect is greater in words that have abstract meanings and words that are lower in frequency. I don't have time for analysis 3, but that's for the best because I've done some more digging into this and it seems to be a spurious result that you should all ignore. So what I did was, for example, looking at behavioral effects like reaction time in lexical decisions as predicted by these edit distances as well as the control variables. And it looks at first like you've got this great clear pattern of a negative relationship, which would indicate that as words become as they sound less similar to, as the, again, we've got, in this case, edit distance on the x-axis. As that increases, they become less similar, and therefore they become faster, which would suggest that arbitrariness facilitates this word recognition stuff, which would be consistent with the story that being similar in both form and meaning creates interference problems. However, this result does not hold up, like I said, because if you do the same things but with randomly paired words, you get the same sort of negative pattern, which suggests that whatever we're observing here is actually due to just neighborhood effects and word meaning is not an important factor, unfortunately. Wish I could stand by the results, but I cannot, so I'll just skip through this stuff. On that pessimistic note, I'll move into some limitations. First important one is that we do not control for etymological relatedness. For example, words like slit and slice, they share some roots in the past, and therefore it's unsurprising that they overlap in both form and meaning. And this is really important if you're going to make claims about language evolution. It'd be nice to claim that this is an adaptation due to selective pressures for the sake of communication or something. But we don't have evidence for that, especially without the word processing evidence, because the words might be diverging in form and meaning rather than converging, and it's sort of a historical artifact. But at the same time, in looking into maybe future work into word processing, it's important to keep in mind that etymology is opaque to most speakers. And so the fact that words are etymologically related versus if they are sort of folk etymologically related, that should not really make a difference in how people process them and how the overlap in form and meaning affects word processing. Okay. Also, we looked at phonological Levenstein distance, which means that we're just looking at, we treat, for example, p and b as different phonemes. So that's an edit distance of 1. But an easy next step would be to do a more fine-grained approach, looking at phonological feature edit distance, looking at all the things that p and b have in common. The effect sizes are pretty small. That's unsurprising, but it does raise the important question of what is an effect size of interest in this case. If I had evidence about word processing, I can make a much more compelling argument that it matters, but without that evidence holding up, that's a point of vulnerability, I suppose. Also, there is a selection bias in the materials, so again, we're using regression models and we have concreteness ratings and age of acquisition ratings. Words that are lower in frequency are less likely to be included in those mega studies and therefore are going to more likely to have NA values. Because they're missing not at random, they tend to be missing because they're unfamiliar low frequency words. We did not impute the means or anything, we just left them out of the regression models. But it would be great to do a more advanced form of imputation to maybe see if we can have a wider range of low frequency words, especially given the effect of frequency that I showed in analysis 2. It's just English. Obviously, it'd be great to do some other languages. It's all computational. That should be a pretty straightforward next step. And finally, we focused on monomorphemic words. I think that's very important as a first step. But at the same time, most of the words we encounter, or at least a large portion of the words we encounter, tend to be compound or complex. It would be great to do the same analyses and seeing whether it holds up when dealing with a more realistic selection of words that includes polymorphemic words. So to sum up, we provided evidence, what I hope is pretty clear, strong evidence, if unsurprising evidence, that words with similar meanings sound more similar than would be expected in an arbitrary lexicon. And this challenges the idea that systematicity is limited to broad categories. Instead, it suggests that the lexicon is basically arbitrary at no levels. Even at the level of individual word meanings, the lexicon is not arbitrary. This effect seems to be greater in words that are low in frequency, so rare words, as well as words that are low in concreteness ratings, so words with abstract meanings. There are reasons why this could be, don't have time to get into it, although I think it's important to note how this differs from iconicity. Iconic words tend to be concrete. These words tend to be abstract. I think that's an important, interesting distinction. And finally, I do not have evidence about word processing, again, that fell through, but there is experimental evidence that we've been working on that suggests that this sort of relationship between form and meaning does impact word processing, and it would be great to look to that more in the future. So thank you for listening, and I'll wrap up and look forward to your questions.
Okay, we have the full 10 minutes for questions, both from the audience in person and we're checking on Zoom. It looks like we have one already at the mic. Go ahead.
Hi, thanks for the talk, Giovanni Cassani from Tilburg University. I was a bit puzzled when you said that there's no study on RTs, because there's actually a few by Marco Marelli and Peter Hendricks where they actually compute systematicity at the word level and show that it facilitates reaction times.
Oh, okay. Is it systematicity of pairs of words with related meanings, or more of the sort of the Monahan stuff with, or correlations between?
We can talk about it more.
Sure.
They construe systematicity as for meaning mappings using different methods, including fast text or linear discriminative learning. It holds up regardless of the way you construe it.
Okay, great. I was not aware of those. Thank you very much for pointing that out.
And there are also some effects of systematicity impacting age of acquisition, which you didn't find conclusive evidence about.
So the ones I'm familiar with would be the 2014 Monahan paper.
Yeah, there's more recent.
Oh, great. Okay, well, thank you. I should know that. Thank you very much. Okay, yeah, I'll listen.
I apologize. So very quick question. You began by saying nouns sound like nouns, verbs sound like verbs, etc. And of course, then you went back to the etymology to point this. But also, it's a bit dangerous to make that claim in English, given the kind of conversions we have. So nurse, for example, can become a verb, to nurse. There are pretty systematic rules about stress differences in disyllabic words. So maybe a safer bet is to use disyllabic rather than monosyllabic, where you can be very sure that as phonologically, metrically, they would be definitely nouns or verbs.
Yeah, thank you. Yeah, you're right. So words like contract versus contract, contract. So yeah, the noun verb alterations in disyllabic words. I think it was Monahan and colleagues in 2005 where they point out that generally disyllabic words are actually a bad way to test for systematicity. Obviously, if you pay attention to stress, very much important, but one of the most reliable effects that we get in terms of inferring part of speech is for word length. So nouns tend to have more syllables, verbs tend to have fewer syllables. So at least from, you're shaking your head, so maybe I'm wrong. What I've read is that in word learning studies, if you have a novel word with 3 syllables or more, people are more likely to infer that it's a noun. If you get a monosyllabic word, they're more likely to infer that it's a verb in English. I think, but to your point about these being unreliable effects, that actually might be supported by a talk that was just given a couple of days ago at the Joint Conference on Language Evolution by Nicole Tamer, and she presented she was looking at systematicity across word classes, and she found sort of a pretty reliable effect for function words versus content words, open versus closed class words, but did not find a reliable effect for nouns versus verbs. So you might be right that is sort of outdated examples that I should leave behind.
Plenty of time for other questions. Is there anyone in Zoom? Excellent.
Hi, Chris Cummins, Edinburgh. Given, as you said towards the end of the presentation, you've got cognates emerging in the system. Obviously, there's some kind of hidden cognates as well, and there's this hint of phonesthemia in the system also. Do you feel there is sufficient pressure to motivate any movement away from having this slightly enhanced level of similarity, or what the dynamics of that change might look like? I wondered if you had any thoughts on that.
Are you talking sound change or what sort of?
Well, I was thinking kind of yes, possibly sound change, possibly kind of lexical drift. I think Andres Cardius has some work on this in very recent times. I wondered if you'd encountered it or had a view.
So, I mean, the question of whether there is enough pressure to motivate this change. So I just presented some work a few days ago, again at that other conference in Japan, using phonesthemes and providing evidence that when you have a word that includes a phonestheme, let's say glacier, or that's a bad example maybe, globe, which has that GL sound but does not actually have the related meaning, people are slower to decide that it's unrelated to a Q word. So if you do a semantic relatedness decision, they're slower to decide that a word like globe is unrelated to a word like shine or light, which would be typically associated with the GL sound. So I mean, that might suggest that there is, yeah, a real communicative pressure to avoid these sorts of pairs, yeah.
I had a question maybe I could ask.
Of course.
You alluded at the end to the fact that this is a stronger effect for low frequency words and abstract words. And then in the methods you talked about the average number of synonyms that you identified being quite high, like 46.
Yeah.
And so I was just wondering if you think this property of systematicity is something about like my lexicon, because I might not have a lot of those words and I probably don't have 46 synonyms, or is it a property that might happen when we look at these large databases? So like maybe that gets to some of the allusions you made to like how it could impact language processing.
Yeah, I mean, so one of the first things that early on I mentioned how associates are a sort of maybe a bad way to measure semantic relatedness, because in many cases they're formally related rather than semantically related. But the fact that they tend to be more formally related when they're lower in frequency, I think might suggest that people do increasingly rely on word form when they encounter these low frequency words. They're more likely to engage in folk etymology. And there's evidence for that I think it's from the recent CogSci conference. The author's first name is Kumar. I'm not sure who they are, but it was doing a semantic fluency task where basically it's sort of replicating this kind of effect you see with associates, where people tend to provide formally related associates for lower frequency words. They found that people, when they're doing, if you have to name members of a category, so name animals, people begin by naming things that are clearly semantically related, but then they increasingly rely on formal relatedness, because as we run out of ideas, we sort of switch from relying on semantic relatedness to formal relatedness. So I suspect that could tie into both the frequency correlation as well as the abstraction correlation. I hope that kind of gets at what you're asking.
Well, let's thank our speaker.